Hey folks, we need to make a special tool. I'm going to do a little lathe work and welding in this video, and so let's get right to it. Alright, so what do we need a special tool for? Well, my special tool is for purposes that shall not be discussed on this video. But this special tool is for pulling. Is that the same thing? No, I guess not. Anyway, so here's what we got. This is a puller typically seen used to pull these guys, which is a rotor or flywheel from motorcycle, ATV, and so forth, all right? Unfortunately, this is the wrong thread pitch. This is a 30 millimeter puller, but it's a 1.0 thread pitch. We need to put a new rotor on this ATV. I know I said I was going to wasn't going to show you more ATV videos, but this is kind of related to it. But I'm actually making a tool instead of working on it. You know the deal. So we got to get this rotor off. The charging system has no output or very little output, not charging the battery. This thing is pretty much worthless without a functioning charging system. How long is that battery going to last to power this thing in ignition and so forth, especially if the lights are on, is probably easily answerable by saying not long. So what we're going to have to do here is we got to get it fixed. Now I've gone through all the tests and I've checked the stator, and the stator tests 100% good. I don't know about the regulator rectifier, which is actually down in here, but you know, the only way to really test an R&R is to have a functioning charging system, and then metering the battery and seeing if the engine is charging the battery. If it isn't, and this tests good, then we'd go to the R&R, which is exactly what I just had to do on the XS11. Yeah, it's still here. Yep, not for long though. Anyway, back to this. We need to get the rotor off because the stator tests are perfect as far as the resistance goes, and no shorts to ground and no opens. Why am I doing this? But what happens is there's very little AC output. Now the service manual says when that happens, the magnetism on the rotor is usually suspect and it's too weak. So we're going to replace it. That's why we need a puller. Okay, so like I said, here's our replacement rotor. Hopefully it's better, but who knows? I mean, they both have magnetism. You can touch a screwdriver to them and they stick pretty good, but may not be enough. I don't know. And you know what causes these things to lose their magnetism? There's two basic reasons for basically heat and vibration or shock. So there is evidence that this thing was overheated. There's no question about it. And number two, there's evidence that somebody tried to get this off because of a variety of findings that I had, the rotor that is, and they probably weld on it with a hammer, and it's no good anymore. That one is no good. This one is the replacement one. So this is what we're going to make. I went to, and I got a M30, that's a big nut right there, M30 by 1.5 nut, which is exactly the thread pitch we need for this. All right? Remember, this is the same as that. Now, what I did off camera yesterday was I'm making this part, the barrel part, out of a piece of fork tubing. You know, I think this is it may be the leftover piece of fork tubing from the Z1R because I replaced those down tubes with aftermarkets. I think that's what this is. I took a long section I have, and well, let's not get personal. It's not that long. But I took that section and I cut a piece off and I started machining it. And so the objective here is we need concentricity as much as possible, because getting these suckers off takes a ton of force, pressure. It's not torque, it's PSI, pressure, force. So you got to make sure that you're straight on that thing when you're cranking any type of a puller. Alright, so let me put you in the stand so I have two hands that I can work with, and I'll show you what we got. Let's go over to the lathe. Alright, so there's three parts to this. You already saw the nut, the big nut that is. And then the barrel, I would call it a barrel, I guess, the middle section. And then there's another nut that matches the thread from that puller I just showed you. I think that's an M12, probably a 1.25, I'm not sure, but it does match it. So we're going to use this as the nut to use that puller section, the threaded section of that one, in this tool that we're making here. So what we have to do for concentricity is I've already done this on this side. What I did was I faced it so I'd have good weld prep to get the scale off, because this is high carbon steel. And so what I did was I also made a counter bore in there, which fits this end right here. Now the surface finish ain't so good. I was having some chatter issues, but it doesn't really matter. It does register up, and that's what this is. This is really called a register. When you have two pieces that go together in a certain way, that you need them to go together, that's a register. So it registers with this counter bore in there to keep this nice and straight, or to keep it concentric. All right, so you get my drift on this. Then what I did on this end was I counterbored that, and I turned this down to fit right inside there. It's actually kind of a press fit right now, but I need to redo this because this is too long. This setup right here is too long. So what I need to do is I need to cut this, or I should say part it down if I can, about yay far. I did part this once yesterday and the lathe just about went ballistic, but whoa, I almost dropped it, shit. Butterfingers. So yeah, what we're gonna do here is part this off a little further down. There'll be some threads in here at that point when we do that, but that's okay. We're gonna rebore that out to take this. Now what I should have done was I should have taken this and put it actually, and I might do that, put it on the bolt itself and then chuck that up. That way I know I'm concentric with the center of it. It may be getting a little too anal, but then turn this rather to make sure it's concentric with the center, and then bore this out to fit that. I'm not sure if I'm going to do all that. It may be fine just the way it is, but we'll see, because I can kind of test that. But that's the game plan here, and of course I'm going to weld it. Now that's a ton of force, like I said before, that's pulling this thing apart, because you're pushing in here, pushing against the fixed part, which is the crankshaft end, and this is on the rotor end, the nut, but this is trying to pull this thing apart. And like I said, it takes a ton. There you go. Yeah, we'll see how many more times I can drop it. This takes a ton of force to do that on those tapers. I mean, they are stuck usually. But we're going to see if we can do it, because I can't find this tool. I cannot find the tool. I mean, I can find it, but it would be weeks, if not a month out. The places I can find the proper tool, in other words, this guy with the proper threads in it, show it in stock. And this is US companies. But then they have a delivery date of like December 20 something. And today is December 9th. And I did this investigation, looking for it a number of days ago, like on the 6th or the 7th. So that leads me to believe that the supply chain is issues are affecting that, and they probably don't actually have it. They're selling it for somebody else. So what's going to happen there is I'm not going to get it in time. So I got to make something, and that's what we're going to do here, like I said before. Will it work? I don't know. We'll figure it out. Let's see, where were we? Fork tubing is actually pretty hard. There's a chrome layer. That's why I turned this back, because I want to get past the chrome down to the parent metal here. And I know I can weld this stuff because I have welded it. I mean, this is the same material that I'm using for the fork, the leading link forks on my sidecar rig. Not this exact same tubing, but the same basic stuff, basically, because what I did was I took that tubing, and that comes off the triple trees and then down into the square tubing, and I welded that years ago, and that's never had a problem. So I'm not too concerned about being able to weld it. But we got to get past this surface material first, and that's why I did that. But we're going to have to redo that because I got to part this off a little shorter, like I said before. I don't know, we'll go to about yay here, something like this. Yeah, it's about right. Whoops, wrong one. When we got, I'm not going to worry about squaring off the parting blade all that much. You want it as parallel as possible. But, I just want to, that's not, there we go, that's better. Now I got to make sure I'm centered on it, height-wise, and pretty easy how you do that. You use a scale. This is an old machinist trick. If I can reach the scale, there we go. I got my little flimsy 6-inch. There's a joke there somewhere. And you just take that, and just so it touches, and when it's completely up and down vertical, which it's not right now, you're okay. So what we need to do is we need to make an adjustment on the doodad stop here to lower it down a little bit. Yeah, that looks good. All right. I'll move you over here so you can actually see the carnage, because I'm sure this is probably not going to work. Now we're going to go in back gear for this. This lathe, there is no freaking way I can slow it down slow enough to operate this thing when regular mode, regular gear. Plus it doesn't have the torque. When you put it in back gear, this thing will basically, it'll twist the arms off of a Gondor or whatever the hell that is from Star Wars, or I don't know, a Wookiee. I don't know. You know that scene from Star Wars, whatever. So, okay, let's get to work here. We're going to go ahead and try to part this. Oh! I don't know if it caught that. I just happened to turn it on right when it was finishing, but it wasn't pretty, but it worked. Alright, now we're back in regular mode here as far as the speeds go. Oh, come on. I got the gib tightened down too much in this, trying to keep the chatter down to a minimum. Keep the chatter down, kids! We gotta clean this up. Alright, now we're gonna take the little skim cut on the OD to clean up that weld for weld prep. I can't do the feed right now. I have it set for a thread pitch and it's too fast, so I'm just gonna hand feed it. Alright, that'll work for that. Now what we got to do is redo that counter bore for the thing. I'm not going to worry about the I don't think I'm going to worry about the concentricity of this. I think it'll be fine. I mean, that's probably going a little too far on this. Doesn't have to be that precision. So we'll put a boring bar in, my little boring bar, which works really well on this. You would think that this boring bar would scream instead of turning on the OD, but remember, it's surface feet per minute, or however you want to express that. And on an OD, it is always more than an ID. So it's the way it is. I'm not going to do any measuring. I'm going to do like go, no go on this. I'd say that's a no-go. Now I could always turn this down to match it too, but really no need. I just need it to register. The wall of this will be a little thinner, but that's okay because I'll get better penetration, said the wife. Ooh, we're getting really close now. Yeah, see? Now let's go ahead and address that, or I should say dress that step inside of that counter bore. All right. See, I'll just tap that in after I clean it all up real good, and then we can zip right around it, and that should weld it in pretty well. I've got one more operation on the lathe here to deal with. An issue is when I do a pusher like this, when I push on a rotor, I like to push on the bolt that goes into the center of the crank, as opposed to the crank itself, if at all possible. These are generally flange bolts in this case, because they don't use any washers or lock washers or anything. And so this needs to fit all the way through inside this. It doesn't all the way, because there's the features inside the inside that tube where I cut it off. You can see in this one it fits just fine. So we just need to bore out the whole thing a little bit more to make sure that that fits. Because again, I like to push I like to push in the bush whenever I can on the bolt itself. Now, you know that's not going to work, dummy. I can't go flush up against the chuck now, can I? And this is just clearance anyway, so it doesn't matter. Well, that's a little too far out. Let's get a little bit of that, a little bit of this, a little bit of that. A little bit of dance, make a little love, get down tonight. Better. Well, it's making a chip. I guess that's all we can ask for. Sorry, I got gas again. Oh yeah, that's plenty of clearance, so that's why I needed to do that. That sucker's hotter than a $2 pistol. Alright, so this is the design, mock-up, whatever you want to call it, for the puller, or the pusher, depending on how you look at it. So I got this tap in there. That's a pretty good fit. And then this is just a, you know, contact fit, whatever you want to call it. It's not a press fit or anything. It's just a register, as I said before. So now we're going to go over into the weld area, and we'll get it set up, and we'll go ahead and do our best to muck it up. I am wicked low on shielding gas. I hope I have enough. Got enough wire, that's for sure. And I'm sure I'm not using the right material, but that's what I got. Turn this sucker up. When she starts making noise, then you know she's ready to burn. We'll go ahead and do some tacks, and we'll be able to move it around at our leisure. By the way, I got the nuts. I got a different one too, but I got this one and that at McMaster Car, in case you're wondering. It'll be easier to... Oh, you know what? I got a better idea. Yeah, let's do it this way. Yeah, we'll do it this way. And I'll do the bottom first and then do the top one. You know, the big nut. That's what she said. Now, if you haven't already figured this out, I'm pretty crappy at welding, so don't judge me. Yow, that's hot. Now I have my wire speed turned down a little bit more than I normally would for this kind of thing, welding, but what I'm trying to do is, because my welder isn't all that powerful heat-wise, I'm trying to hover the puddle a little bit longer, especially over the thicker part, the bigger part, which is the nut, try to get a little bit better penetration. Will it work? I don't know. We'll figure it out. I'm thinking if I get it, since that's a sharp corner, you know, where this thing sits into that counter bore, it's an outside corner. I'm figuring I'll get some really good penetration on that corner, and as it sticks up, and that way it'll help hold this thing together when we put this kind of torque on it. Not torque, force. Put this kind of force on it. All right, let's let this thing cool down, and here's Ichabod, and then we'll see what we got. All right, this is what it looks like. Cleaned it up on the wire wheel a little bit. Yeah, it looks like an abortion, but you know what? I wasn't paying too much attention to aesthetics here. I need penetration and this thing to hold up. So the last thing we need to do now is try it out. Okay, like I said, I want to put the bolt in. The way I'm pushing up against the threads and not directly a very high contact point on the end of that. And the reason why I'm doing this is because I figured that what happened was this end of this crank here was all kind of mushroomed out, and I had a really hard time getting that little bearing off. So I figured somebody was putting a puller of some sort on this directly at some point. This will at least give me some help to disperse that force through the threads into the shaft. You said shaft instead of the very end there, the very tip. Just a tip and just for a second. So this should fit like this. If I did my job right. Hope I made it about the same length as the other one, and I kind of toyed with the other one to see if it would bite enough to take it off, but of course it wouldn't. So, oh, that's on there. Good. So let's make sure that that is where we want it to be. Okay, so yeah, it's good. It's good. It just is a little bit further out toward the end than I wanted, but it is going to work. All right, so what we're going to do here is get a wrench to hold this so it doesn't turn, and then we'll wail on this with the impact and see what happens. All right, folks, moment of truth. See what happens. So I can get the freaking socket on. Look at that. Look at that. I could not get that off for the life of me. Woohoo! Yeah, baby. Definitely. Definitely. Oh, yeah. Now, let's take this off. The end. Whoops. Oh, is that the right size? No. Of course it isn't. I gotta remember what it is. I think that is a 14. If I'm mistaken. Not mistaken, rather. Probably mistaken. I'm always mistaken. Yeah, and no worse for the wear on the tip there. Now this is what I've been trying to do for days now. Days. I've been trying to get this off. This is the starter clutch. This has to be removed, put over on that flywheel, but that's not going to be a problem. You have a woodruff key in here because this also provides your timing mark, so it would make sense that it's keyed. All right, so all right. Now I'm not going to show you all this repair on this bike. I will report. I'm not going to go any further on this on camera, at least. The whole point of this video was to show you the tool. Show you my tool, sort of. So, but what I'm going to do is I'm going to get all this back together, and we'll put some fuel to it, and then I'll show you whether or not we repaired the charging system. At least you see that part. So I'm going to go ahead and shut down the camera now, and we'll get this part done, and then we'll come back and I'll show you whether or not the charging system is repaired. All right, folks, we're at nominal voltage in the battery of 12.59 volts. This was a real prick to get back in. The problem was there's a woodruff key, as I think I showed you on that rotor, and so when you try to get this assembly in with the starter clutch assembly in there, all it wants to do is knock that woodruff key out of place. It falls down in the case. Now, luckily there's not a big hole in there, for it to go. So I just had to keep redoing it until I could finally get it to work. So I finally got it set in, and I started to put the stator cover back on, and of course it sucks the rotor right off, and I'm like, what the hell? So I have to redo all that, and I'm like, well, how the hell do you set this? And then I went, wait a minute, this is a taper. So I just put this driver for the recoil start on, zapped it up really quick with the impact, took it back off, and then that set that on the taper. Then you shove this in. I made a gasket for this. The gasket's not available anywhere. I think it went the way of the dodo bird, and so I had to make it, and that's all I could use. What they had used going in here before to mess with this is simply goo. So that's what I did, and I got that set up. So let's go ahead and see what our charging is going to be on it right now. I did start it up real quick, but then I put the meter on it. I just want to make sure it would run. Yeah, let's see, where are we? Well, that's not bad. $13.7. I'm not sure why it goes down when you rev it up. That's weird. Huh. It's got to be the regulator doing that. The regulator's got to be controlling that. Maybe at a higher RPM it doesn't need that much. I don't know, but it's definitely charging now. Alright, we're going to have to fiddle with this carb a little bit more, I think. But anyway, that's not for this video. This video was to show you the special tool to make the, the special tool to get that rotor off, which obviously we succeeded in. I got it back together. I showed you that it is charging now, although it's not great. But that's it. Okay, so this video is not all about repairing this. I said that before. It's just about making a special tool to get the rotor off. I was able to do that. I showed you how I did that. Maybe it'll help you. I got the bolt, the big nut rather, from McMaster Car, as I said before, and then just a little lathe work and some welding, and boom, we got some to pull that rotor off with. Got the replacement rotor on. We are charging somewhat. It's charging weirdly, but it's charging. So it wasn't doing that before. Probably acceptable. This engine's smoked anyway, as I said in an earlier video or videos on this. And so it's just going to last as long as it's going to last. So, but we did definitely have to have a battery charging, at least somewhat. So, all right, if you like what you saw, you know what to do. Ring the bell, subscribe, get notifications when I put more junk like this up. Like the video, that definitely helps. Of course, dog's barking now. And the other stuff, the analytics side stuff, you know what to do. You're smart. You watch YouTube. Don't just repair, restore. Catch you on next video, and thanks for watching.